All right, so step 6, the O in phantoms is to obtain the p-value. And again, we're going to make a picture to try to make sense out of all of the numbers. And so the p-value is the value next to p on the calculator, but again, keep in mind it's actually the p-value. And so if we're looking at StatCrunch, all we can say is that it was less than 0.0001. If we look at the output screen on the calculator, we had 1.85 times 10 to the negative 10. So if we back up a page here and look at our output screen here from the calculator, it gives us a little bit better idea of how small it is. Okay, so, but again, less than 0.0001 is enough information to let us know that we need to reject this null hypothesis. All right, so again, if we draw the sampling distribution of the mean to make sense out of these numbers, again, we're using a t-test, so we have a t-curve. Quantitative data, we're dealing with the random variable x bar, and we're running a t-test, so each value of x bar will have a standardized score or a t-score that goes with it. So again, our claimed value goes in the center. So our claim was that mu was 79.8, so we would expect a value of x bar near 79.8. The t-score for center is 0. What we actually saw in the data was a sample mean of 73.736. So it's below 79.8. How far below depends on two things that we could look at. So the t-score tells us that 7.71 standard deviations below the mean, so that's really far. But again, the p-value gives us a better idea for most people with probabilities. And so that p-value rounded to 4 decimal places is about 0.0000. And in this case, we were comparing that value to 0.01. So the level of significance given at the beginning of the problem was 0.01. And so this p-value is definitely less than or equal to 0.01. So our next step is M, which is make a decision about H0. So in this case, we're going to say since the p-value is less than or equal to 0.01, because again, that was our given value of alpha, we reject HO. So again, unusually low value tells us that we don't believe this is the value of mu. We think it's lower than what they claimed. So in step 8, we're going to say there is significant evidence to conclude that the mean life expectancy for all, so again, the power of inferential statistics is that our conclusions are about the entire population, so that word all is really important in there, of all European men in 2011 was less than the mean life expectancy for European women. And that, again, that was what that 79.8 years was that they had given us. So in this case, we're going to say there is significant evidence to conclude that the mean life expectancy for all European men in 2011 was less than the mean life expectancy for all European women in 2011. And again, that was that 79.8 years, if we wanted to, that was the specific value we compared against. Okay, so in all of these problems for hypothesis testing, we are going to be, again, just using these same steps for phantoms. It's just the parameter will be different. If it's qualitative, we're dealing with proportions, and if it's quantitative, we're going to be dealing with means. And there'll be different conditions to check for qualitative versus quantitative data, but those will be on our cheat sheet. The formula for the test statistic will be different for qualitative and quantitative data, but again, that will be on our cheat sheet. But then where all the numbers go on these distributions and how we make our decisions and draw the conclusions, those are the same for all of these tests.